Hello, everyone. Welcome. We are going to get started. So I'm just going to do a little bit of an introduction, and then Ria will start with her keynote presentation. And then after that, we will be doing a bit of Q&A. So my name is Cara Dveris. I'm the Projects and Administration Manager for North Forge, and I also run the Elevate IP program. North Forge is located on Treaty 1 territory and is in the national homeland of the Red River Métis. We honor the Anishinaabe, Anishinaabe, Innuit, Dakota Oyote, and Métis people as the original caretakers of this land. As a not-for-profit innovation hub, North Forge recognizes its responsibility to listen, learn, and act. We are committed to respectfully supporting Indigenous cultural identities and integrity by incorporating Indigenous knowledge and leadership into our programming, governance, and community relationships. North Forge is a not-for-profit tech incubator, accelerator, and state-of-the-art fabrication lab. We fuel Manitoba's innovative, science-based, technology-enabled, and advanced manufacturing startups from ideation to funding by offering unparalleled programming and resources to help startups grow. Our facilities boast one of North America's largest publicly accessible fabrication labs where startups can access cutting-edge tools and technologies. Thank you for joining our Elevate IP webinar series, where we host reputable experts in the intellectual property field to share their valuable insights on various aspects and topics. Over the past 3 years with Elevate IP, we've provided expert guidance to startups in Manitoba and Saskatchewan, empowering them to leverage IP as a valuable asset in their growth strategy. From funding patent filings to tailored IP strategies, we've seen firsthand how critical IP management is. Our program has served over 700 startups in Manitoba and Saskatchewan at this point, 47% of which are women-owned or Indigenous-owned businesses. Through strategic partnerships with top-tier law firms, service providers, and IP advisors, we've offered invaluable support while educating entrepreneurs on the long-term value of safeguarding their innovations. To date, North Forge's Elevate IP program has facilitated the development of over 50 IP strategies and supported over 250 IP filings, including patents, trademarks, industrial designs, trade secrets, and copyrights. It is now my pleasure to introduce today's keynote speaker. Riya Ganguly is a seasoned leader with extensive experience in technology, commercialization, innovation, and entrepreneurship. She is principal and founder of an IP strategy consultancy called Mauve Innovation. In addition, she serves on several board and volunteer committees, including as the chair of the board for Women and Wealth. Throughout her career, Riya has held senior and VP positions at economic development organizations and 5 post-secondary institutions across Western Canada. She possesses expertise in board governance, technology transfer, and building strategic partnerships. Riya holds an MBA from Queen's University, a PhD in physiology and pathophysiology from the University of Manitoba, and an MSc degree from York University. She is also a certified corporate director. In addition, Riya has been awarded several academic and professional awards, including being named one of Edify's top 40 under 40. In her personal time, Riya enjoys long distance running, yoga, and hiking with her family in Edmonton's River Valley. Riya, welcome. We are so excited for your presentation. I will let you take it from here.
Thank you so much for having me. I really appreciate it. I'm just going to start by trying to share my screen. So we'll see if that works the way I want it to. It looks like it does. Okay, so as Cara mentioned, my name is Riya Ganguly. I have held a number of different positions across Western Canada, but the one that stays the truest to my heart is my time working in technology transfer. And that's really going to be the basis of today's talk. So I'll just give you a little story about me. So I did my PhD in physiology. I was interested in cardiovascular disease, specifically looking at heart cells and how different fats impacted whether or not those heart cells would live or die. A little bit more complicated than what I'm saying, but hopefully it gives you a basis. Around the 3rd year of my PhD, I thought to myself, I really love science, but I really love to talk as well. So how do I marry these things of like being able to be connected into the world of deep research as well as be connected into the world of potentially business? And I truly fell on this area of technology transfer. I started working at the University of Manitoba in the technology transfer office under the guidance of Dr. Darren Fast, who, if you have not met him, is an incredible leader, an incredible human being. And he taught me everything that I know about how to take ideas from the laboratory and really find a path towards commercialization. And that can look different, and we certainly in today's talk will be talking a little bit about what those different paths look like. But ultimately what I want to impress upon you is that there are a number of ways to take this deep research that's coming out of the laboratory and find a path to commercialization. And it's incredibly exciting. So today's talk is relatively informal. So I encourage questions and ideas. Certainly as the talk ends, I'm really excited to hear what you guys think. But my hope for the takeaway today is to inspire some level of thinking around how we take things from the research lab and move them forward. As Cara mentioned, I also had this incredible opportunity to be vice president of a foreign direct investment agency here in Edmonton called Edmonton Global. And during that time, I learned very quickly how important it was not only to take ideas from the lab and commercialize them, but how important that was in terms of yielding a public benefit as well as an economic advantage. Commercialization ensures that public investments in research yield tangible benefits. It fosters innovation clusters. So things like what you're seeing with North Forge, they're available because we're finding ways to commercialize technology and create new opportunities within our different arenas. We're attracting venture capital. We're strengthening Canada's global reputation in science and technology. So this is not to be ignored. This isn't a small area, because in 2023 and 2024, over 13,000 jobs were created by university spinoff companies. And these companies generate more than $3.5 billion in annual revenue. So not small. And Canada's doing quite well in this space. We're not only being able to find things through discovery-based research, we're actively partnering with industry to find solutions that are going to meet industry needs. And so we're finding through that, so what I hopefully the next set of statistics shows you is that we're actively doing R&D contracts, not only with other partners, but also with industry partners. And that's ensured that we're increasing our invention disclosure. So invention disclosure is when you're working in a research lab, you think you have an idea, and you go to the technology transfer office and you're able to say, okay, you know what, I think I have something. I want to make sure that I can take that to an actual technology. And so we see that from 1998 to 2009, now this is a little bit dated, but I think this is best what we could do. We saw the invention disclosure rate increase from 661 to 1,428. In my experience, in the sort of 5 post-secondaries I've worked for, 4 that were universities, the average rate of disclosure for institutions is about 100 to 120 per institution. And that's happening annually. So that's not bad. Like, you're seeing about 100 new big ideas, over 100 new big ideas per year coming out of the institution. My excitement and my hope today is that all of you kind of take away, we can increase that rate through some really interesting and meaningful ways. Because although we're doing quite well, our IP index filings aren't as high as what you're seeing in other countries. We're certainly not meeting within the top 10. And more than that, we know that there's an opportunity to do better with respect to research and development from post-secondary. So in 2017, the government spent about $5.7 billion in research and development, and that obviously increases year over year. So the last stat that I have is $18.1 billion in 22-23. But Canadian universities and research institutes only generated about $75 million in income from licensing IP. That means that although we're spending quite a bit on research, there's a huge opportunity to do more when it comes to finding out that IP and then finding a path to commercialization. And there's this bigger narrative happening, certainly here in Alberta, but I think in many provinces that really important institutions like ElevateIP are at the center of is, how do we not only protect that intellectual property, but also keep it here in Canada? So in 2016, 58% of the patents granted to Canadian inventors were actually assigned to companies located outside of Canada. And that was up from 2005. And why I think this is important is because we know that a path to commercialization, in looking at a path to commercialization In some cases, licensing is the best path for that technology. But we don't want to be just reliant on that. We do want to find more ways of being able to create startups from deep tech research happening within the post-secondaries. There's been a lot of talk around this, particularly when we're investing in big areas like AI. In 2023, it was estimated that 3/4 of patents produced by researchers who worked at Vector and Mila, which are their big AI agencies here in Canada, were actually left the country and are in the hands of big tech. And this is really important because companies with a core business in intangible assets, so in IP, now make up about 90% of the S&P 500. So we want to not only create more intellectual property, we want to find ways to keep that IP here in Canada where we can, because we want to rank better in the Global Innovation Index. Again, when you see this stat on the graphic on the right, hopefully you can see very quickly that we don't, again, stack within the top 10 in Global Innovation Index. And yet I'm sure all of the people sitting in this room can say, Canada is an innovative country. We're doing innovative things. We can find better paths to commercialization. So in today's talk, what I hope you'll take away are some techniques and ideas in terms of being able to identify intellectual property. Oh, I think I might have missed, oh, not for mine. Be able to identify intellectual property, find a path towards IP strategy. I know that the previous talk that was had did a lot in terms of looking at IP strategy. For those that didn't attend that talk, highly encourage it. But I hope that some of the things I talk about today will continue to encourage that focus on IP strategy. We want to find support for IP commercialization. So there are institutional resources as well as government programs that people can access to support their IP commercialization. I'm going to be really clear here. I'm not providing in any of these instances an exhaustive list. What I hope you can take away from today are just some strategies and techniques to ask those questions and find those resources so that you can find your own techniques or your own paths. I also want to look at some funding considerations and agreements, again, not an exhaustive list, and some startup tips, some things that I've seen in my own time that hopefully inspires you to think about, specifically if you're a researcher or wanting to work with the researcher, how to kind of look at those startups and find a way to maybe build teams around those startups. Because there's some huge considerations when we're thinking about the current state for research here in Canada. Many researchers, myself included, so I can say for certain that I did not, through the course of my master's or PhD, have any training on IP management or commercialization. I am certain that it was available to me. I absolutely am certain of that. It just did not feel core to what I was doing. And so I would say that we do have an opportunity to continue to inspire more in that space. Now I'm dating myself a little bit. I did my PhD about 15 years ago now. I'd started it at that time. So, you know, a lot has changed in that time, and there's certainly more programming in the space. However, I think we can always do more to support it. Many technology transfer offices, not only in Western Canada, but across Canada, are underfunded and often under-resourced. So they often can only get to that 100 to 120. So it really is an opportunity for researchers themselves to start to look at their research and say, hey, there's something here that could be really interesting. I wonder how I can commercialize it. There's also sometimes a difficulty matching particularly discovery-based research to industry needs. So here's an opportunity for those that are partners within the room today to start to think about, hey, I really want to grab onto a big new idea. I think there's an opportunity for me to develop something in my space. The university may have something here. How can I work with them to start to co-develop something? In the working of doing that, there's often a misunderstanding of the IP policy within the post-secondary institution. Too many times I've seen in the post-secondary institution, particularly working with industry partners, a hesitation to work with the university because they feel they don't have strong understanding of the IP policy. Speak to your technology transfer office. There's a huge opportunity, I think, to think this through, and we'll talk a little bit about that today. And I also think there are a few standardized indicators in commercialization success. From an early stage, it's really hard, particularly in grant funding, to demonstrate success. Often KPIs associated with grants are things like number of jobs created, revenue. And if you're at a very early stage, that's hard to create. So I think we do need to look at some early stage indicators of commercial success to support those early ideas to move down the pipeline. So I am the type of person that likes to think about this in examples. And I looked at the ICD website and they had this great example that I would like to walk through today. So several years ago, there was a researcher from a university in Quebec who was an engineer and a specialist in transportation equipment. They were involved in developing a new snowblower support system, an innovation that reduces the risk of damage to wheel loaders equipped with a snowblower. Now, sounds cool, right? Engineer, they've created something, obviously, with a very specific application to snowblowers. What I think is the only takeaway I'd ask for today, if you can't take away anything else, because there's lots of information coming at you, is that the researcher was convinced. They were convinced this was a promising technology. And that's often the biggest hurdle. I have met hundreds of researchers in my career. I've worked in the sort of tech transfer space in at least 4 post-secondary institutions across Western Canada. And the biggest barrier I've seen has been an inability to be convinced that this is a promising technology, that it has an opportunity for commercialization. So for researchers in the room today, my only ask would be, can you walk away thinking, hey, what I'm doing, is there a commercial application here? Is there something exciting here? Because certainly this researcher saw that. And they received support from their TTO to obtain a patent. So this part of the case study is always interesting. They say, after many steps and much negotiation, and I agree with this completely, and it seems a lot, it's certainly stated a lot simpler than I imagine it was. Often once a patent is going through, particularly in a provisional stage, in a technology transfer office, that's really the first step to going, who's interested in this and how do we move this along in a meaningful way with a partner? So at least from my own practice, once we went into provisional patent, often we would start to call different areas, different companies to say, oh, is this something that you might be interested in? And how do we ensure that we can support a path forward with you, right? So I think that's going to be that after much steps in negotiation, it's not one call, it's several, sometimes tens of and 20 calls that we're doing to really find that match for the technology and the company. But luckily they did do that, and they found a Quebec company called SM Suspension, which luckily held contracts for road maintenance in Quebec's transportation ministry. Another piece of this case study that we'll go into, and certainly we'll delve much more deeply into a lot of these areas through the course of today's talk, because this was a first-time family-owned business that had managed IP, the company directors were very smart because they made a point of learning not only what a patent is, but also about royalties and how to negotiate a licensing agreement. And they didn't do this alone. They found much more experienced partners to support them. And this is another thing. Partners often also play an incredibly important role in making sure that commercialization path can be successful. So it's not just about the researcher identifying the technology. It's also about the company thinking, how can I do this in a way that's going to be beneficial for me, but also support this relationship that I'm having with the researcher. Because SM Suspension not only acquired a license to this technology, but also committed to taking on products and improvements, which could mean patents for those improvements and thus new sources of revenue. So what I'm thinking of is 2 spaces here. I'm asking you as a researcher to think about this critical question. What I'm working on support a commercial opportunity? That to me is often the biggest thing that doesn't happen frequently enough in order for that sort of IP disclosure rate to increase. And ask yourself, is this patentable? And we'll go through a couple things to think about in terms of whether or not you can identify it if it is patentable. Specifically for researchers, because so much of what is done is publish and perish, we do want to think very carefully about whether or not you've disclosed this technology prior, because that will impact whether or not you can get a patent. So we know that a lot of times when you're looking at disclosure, researchers are constantly thinking about how they're going to publish their research. So I would say, please ask yourself, did I potentially already disclosed this technology in a publication and or a talk. But if you haven't, and you feel like this is an opportunity for patent, ask yourself in the next step, what is the path to commercialization? And again, we'll go through this. And in not everything that's patentable is commercial, and also things that aren't patentable can still be commercial. So of course, I'm sure you've heard this many times, the trade secret of KFC. So KFC, their recipe is a trade secret. No, nobody knows what the recipe really is, but they made lots of money using that recipe in their chicken, and in the chicken that we're eating. So not everything that's patentable, is commercial, and also not everything that doesn't have a patent doesn't mean that it isn't commercial. So please ask yourself, is there a path to commercialization, whether or not the technology is patentable? And then another big area of focus for me is, who do I need to work with? It is something that I see over and over again, that a researcher will try to take this out on their own and probably needs some support, but maybe doesn't know who to talk to and when. And that's when that sort of support community can help them. And again, we'll go through it. For partners, I think there's a huge opportunities to help to shape research questions. So you can really support the researcher rather than trying to make them fit a box. Oftentimes I've seen a company come in, they don't see exactly what they're looking for in the research work, and they walk away. But there might be nuggets of their interest that are part of the work, and maybe additional funding and additional support can really make that that research and industry partnership work. So I think ask more questions, really get curious. If you don't fully understand the technology, ask, like that previous example did, who else do I need to be a part of my team? Who else do I need to ask to make this work? And then ask yourself, how can I structure an agreement that's suitable for both myself as the industry partner, as well as the researcher? So again, I'll give you a couple of examples of where I've seen this. One is I'm currently working with a researcher in perinatal health. This individual was looking at a very basic molecular mechanism to understand preterm birth. And what they did is they found a drug target that could block one of these pathways. And what they found is it reduced the rate of preterm birth. And now they're working on an active commercialization path to support a startup in the space, but also an opportunity to move this along with a bigger company. So I would say there's big opportunity in terms of asking yourself the question, and this is a basic research project, does this have a commercial application? On the flip side, I had the opportunity to work while I was at the University of British Columbia with Rogers Communications. And this is a really great example of how Rogers brought this big idea of trying to figure out wildfire detection with researchers using 5G technology. And I would just encourage, because just for the sake of time, to click on this link and take a look at how this was done. Because again, I think what I want as a takeaway for today is for partners that are interested in research to say, hey, there might be a question I have that a researcher can help me with, and try to find that path towards partnership, because that's going to support the commercialization journey as well. So people often ask, okay, I'm a researcher, I don't know anything about patenting. I'm like, I know, I've been there, I understand completely. There are some really clear indicators, at least in terms of the patenting world, for researchers to start to look at when they're thinking about, is this a patentable opportunity, something that might be differentiated in that way. So is it novel? Asking yourself, is this new, never been done before? And I gave you an example there. Asking yourself, is the technology useful? Making sure there's a clear use for the technology. And then asking yourself, is there a commercial application? And I give you another example there. And then asking yourself, is it non-obvious? Is this more than an improvement? So I'll walk you through this one, because this one is the most non-obvious. So imagine someone patents a smartphone with a solar panel on the back. If solar panels and smartphones are well known and combining them is straightforward, the patent might be rejected for being obvious. But if the inventor solves a technical challenge, like integrating solar charging without overheating, that could potentially make it non-obvious. And there's an example of this that I had the chance to to be a part of a little bit of my time at University of Manitoba, there was a researcher working on a aortic annular ring. And this individual had sort of built this aortic annular ring. We knew that there were rings that you could use for other parts of your heart, like the mitral valve, but they were able to create something very different for the aortic valve, specifically in the way that it was created. And so because it hit the non-obvious component of it, they did in fact manufacture this ring. And I believe there were some really interesting commercial outcomes associated with it. So all I want to do on this example is let you know that, it may feel obvious. I would say go through the journey of, is it non-obvious? Work with your tech transfer office, work with colleagues that are part of this team that you've created to support that path and understanding. And then ask yourself, what do you want to do with it? It's, beyond this, the impact of startup, I think it's really important for the researcher to ask themselves at the very beginning, what do you want to do with this technology? Do you want to license it? This is quite common, especially in the world of health research, because it can take quite a long time to take a drug to market. So licensing can be a really important way to kind of get that technology out into the hands of a company that can use it. Or do you want to create a startup out of it? And if you do want to create a startup, think about your team structure. Think about revenue sharing with the institution. Ask yourself some questions around equity and royalty structures. The tech transfer office, as well as websites, will give you a ton of information here. We'll go into a little bit of detail, but hopefully this gives you a starting point for some questioning. Because there are pros and cons to starting a company, right? Researchers are busy and do a lot with their time. Like, they're not only doing research, they're often managing labs, they're managing teaching, they're managing other administration within the institution as well. And being so busy, often the question is, do you want to take this on and participate in a startup? There's pros like having full control and potential upside, brand building, you can attract investment. Some people really like doing that, but the cons are it's high risk and cost, it's a long time to revenue. You do have to manage things like the IP protection burden, but also just, I would say, time is going to be the biggest piece with creating a startup. In licensing, you have lower upfront investment. It can be a faster time to market. It's a steady revenue stream, so things like that can be important. You do have limited control, lower financial upside. You are dependent on the licensee's execution and commitment. So it's something to just take into consideration when you're thinking about your licensee, and having those conversations up front with the licensee through your tech transfer office to say, what are you really committing to, and what's kind of this path towards commercialization that you see. And also there can be poor implementation by the licensee that can harm the technology's reputation. So some things to consider there. We talked a little bit, I know in the last talk did a really good job of going through IP strategy. I won't go through so much detail here because it was done incredibly well in that last talk. And I did take this diagram from that last talk. All to say that there are a number of considerations I think inventors need to take into consideration as they're thinking about their IP strategy. Some things to keep in mind is that basic IP landscape. How do you fit in that grander scheme of the IP landscape, and providing yourself an innovation roadmap? Thinking about your IP portfolio and increasing your competitive advantage. And of course, things like IP risk management. You want to reduce your liability and uncertainty. When I think about this myself anyway, I think about a company and I think about the different roles within the company and how they're going to support the IP strategy. So I think about, okay, if I were to build a company, I'd want a chief technology officer. That person would really be involved in the innovation and patent strategy. They would be building new and creating new. I would think about a chief marketing officer marketing that technology and creating brand management there. I would think about human resources. As I'm hiring more people, I want to think about confidentiality and non-competes, because that's going to be important to support that technology and its success. I'm going to think about what my chief operating officer is going to do with that IP strategy in terms of procurement and supply chain management. The chief financial officer, and thinking about things like financing and tax credit and transfer pricing. But also I think really important is, and probably the one that is going to be really important for enforcement is general counsel and legal to ensure that IP protection is in place and also enforced. There's a strategy for enforcement. And then there was a lot of talk, I think, in that last conversation around IP and business strategy. So these things need to be connected. They're not separated, right? So we're thinking about the company and we're thinking about the different roles within the company. We're also going to be thinking about who we are, right? In terms of our business strategy, where we are. So looking at that IP component in a SWOT analysis, doing performance analysis and data. We want to think about where we want to go with that technology, the goals and objectives with that technology. We want to think about how we know we'll arrive. So what are our performance and targets? And how are we getting there? What are the actionable steps we need to take from potentially a bench scale level technology all the way out to full company, if that's the choice we're making with the IP? And there are some major considerations for research here. Often we can be identifying IP at a very early stage of research. So if it's at bench scale, maybe it can be produced at bench scale. Does it need to be, what supports need to be around that technology in order for it to be produced at commercial scale? If it's in health research, well, there's a number of considerations here. I'm only giving you a few, but what's required for this technology to go from an animal model to clinical trial? And then there's a number of pieces to consider through the course of clinical trial. And what regulatory considerations do we need to support that technology? And then, of course, how much does this all cost? And this is really where your support system is going to help you. If you're a researcher within a university or a post-secondary environment, you have access to a technology transfer office. They're really the commercial arm to supporting this technology and its growth. So you're going to see that the very early stage researcher goes to tech transfer office, discloses the technology, an assessment is generally provided. IP protection may or may not be granted depending on the assessment. Marketing is done if licensing is going to be the path here. They're going to select a licensee, license it, and commercialize it. And then there's an opportunity for revenue and reinvest. So this is going to be focused on the licensing part. There is a slightly different circle when you're looking at it with respect to startup, but many of the steps kind of are similar there too. Because ultimately they're trying to create a roadmap towards commercialization. And so that innovation component of it and invention disclosure component is really critical because that's going to allow them to understand what's possible with the technology and provide that meaningful assessment. And these are really incredible individuals. Like I've worked with 4 technology transfer offices across Western Canada, and in every instance, these are major professionals who have seen a number of technologies and have so much to give in terms of advice and support to helping that researcher think about their technology differently. They're going to help with the commercialization assessment. And like I said before, in some cases, they will help you through the course of starting your company, at the very least provide terms and supports to starting a company or helping to find a partner. And then they can negotiate a license into that company if that's the right strategy, and then follow up and support. So you're a researcher, you're thinking, okay, how do I do this? How do I get connected into this black box of commercialization that happens within the post-secondary? My big advice would be come with a plan and an open mind. So I talk a lot through the early stages of this talk around helping researchers understand what's commercial and patentable in their portfolios. But I've always advised, like, once you're hitting the tech transfer office, that's going to be a second pass. You really want to come in with an open mind to saying, okay, I think this is what I've seen. What are you seeing? And then how do we work together? Because ultimately, we're all here to support the researcher and what they want to accomplish. I think there was a question here about the IP policies in different institutions. And so there are different IP policies that govern different post-secondary institutions. Some are institutionally owned. So there are instances of technologies where the company, university, and legal entity actually own the patent. And Ottawa can be an example of that. Now that's a blanket statement. There are a lot of caveats to that statement that may or may not be in place if a funding agreement is in place, if there's a partnered agreement in place. So just because they own the technology doesn't mean that in all instances is it applied that way, depending on some things like like the whether or not they hit a sponsored research agreement, that might shift depending on the terms there. So it's not blanket, it's not simple at all. And there's also something called an inventor-owned policy, which allows the individual who conceived the invention to retain ownership of the patent. The best example of that is the University of Waterloo, which has their creator-owned IP policy, which states that inventors retain full right of the IP developed through their research. So those are the policy components of it that I want to be very clear. It's not black and white at all. Like, at least has been my experience. Work with the tech transfer office, understand what's possible here, and develop a path based on that. And also understand your funding agreements. Like I said before, in some agreements, it's stated that the partner might own the IP through the course of the agreement. And if that's mutually agreed upon by the TTO, yourself, and the partner, then that's kind of the way the IP is going to be supported towards the path towards commercialization. So make sure you understand that before you sign that agreement, and understand where you stand with the IP policy as well. And I really think this is important because I'm a big fan of tech transfer and tech transfer offices. Nobody's perfect, but like I said, I've had this beautiful privilege of working with 4 post-secondary institutions and working directly with or within the tech transfer space. Please see the TTO as a member of your team. These are, again, incredible professionals that can help support and guide you and can help make money. This is a good example of that through the University of Sherbrooke, where there was a researcher who developed a revolutionary voice compression algorithm. It has a very specific acronym, ACELP. It was designed to optimize speech quality over low bandwidth networks. They worked with the University of Sherbrooke on patent protection, global licensing to telecom giants, and then actually adopted a non-exclusive model to maximize adoption. And it was adopted in over 95% of mobile phones worldwide, generated over 200 million in licensing revenue, and became a global standard in voice transmission codecs. So there's a lot to be gained by supporting this. And this is an example of licensing. Another example is company formation. So AbCellera Biologics is a company that was founded out of UBC by Dr. Carl Hansen. They developed a proprietary platform that rapidly screens immune cells to identify antibodies and played a very important role in therapeutic antibiotics, including COVID-19. So they partnered with major pharmaceutical companies like Eli Lilly, went public in 2020, raised $500 million in its IPO, and became one of Canada's most valuable biotech firms, with a market cap exceeding over $5 billion at its peak. So UBC did support AbCellera through Innovation UBC, providing licensing mentorship and commercialization pathways. So I think, again, we want to double down and saying, like, get support, because it does help in terms of supporting big ideas through the course of licensing and or startup formation. And there are additional supports. ElevateIP is a great place to go. There's also Canadian Intellectual Property Office. There's IP Assist through NRC IRAP, and these are all applicable at different stages of your technology. So figure out where you are and figure out, maybe there's a place for ElevateIP, and they can help navigate through some of these other resources as well. There are independent consultants that I've seen some companies will connect with to understand a little bit more about their IP strategies, and you can also work that in through a funding agreement. There's hubs within the institution, like EIUBC is an entrepreneurship hub that supports researchers and or students as they're thinking about big ideas. And then, of course, we're so lucky and fortunate in Canada to have innovation hubs also outside the institution that can provide resources and support as well as navigation. So 2 things maybe for the researcher has to take away. One is understanding that your technology has a ton of value, or it could potentially have commercial value. The other one is, have you looked at your funding agreements? So I would ask for researchers, look at your funding agreements, understand if IP has been negotiated in your contract, and understand the terms. So does the company own the research? Is it jointly owned? Are there revenue sharing terms? Just understand that and work with your TTO to really get a better sense of what that looks like, as well as understanding background IP. So everything developed prior to entering into the agreement, and then foreground IP and who owns what and where in that spectrum. So ensure you understand your IP terms also prior to working with a company. So ask these questions as you're working, as you're starting to think about developing a contract with the company. And don't forget your TTO in these discussions. You want them there as part of your team. And have the conversation with the company if you think something could be commercialized, and ask yourself what you really want to do with it, if that's something that's of interest to you. I'm going to go, I think I'm sort of running a bit low on time, but partnered research has lots of benefit, both for the company as well as the institutional partner. MyTex is a great example of that, developing opportunities for students to participate in these research projects that are, coming from industry. And this is a good example of that with Darwin AI, where the team developed a novel method called generative synthesis to make deep neural networks faster and more efficient. So in this instance, company comes in, works with the University of Waterloo. They receive MyTax as a support mechanism to get students working on this project. And then some of the technology that was developed was adopted by major companies. They raised millions of dollars, and their tools are now used in industries ranging from automotive to aerospace to manufacturing. So some of this is, I think, as a result of being open to a relationship with the institution. And then, if you're a researcher, ask yourself, again, what do you want to do with the research? Funding should really be determined on what you want to accomplish. Look at the terms of the funders prior to signing, and then create parameters to support your IP and business strategies. There's a lot of examples of funding to access. I gave you one around MyTax, but there's sponsored research, so working directly with the industry partner. There's also follow-on funding you can receive through Tri-Council. There's a big program called Lab to Market, which really is a support mechanism for students as they're thinking about their research in an entrepreneurial way. This is an incredible program worth taking a look at. There's also provincial funders like Alberta Innovates and Research Manitoba, NRC IRAP, as well as big federal funders like CFI, which is really there for infrastructure funding, but can be there's potential opportunities for commercial application as well. And then in the last couple minutes of today's talk, I'd like to go through a couple of startup tips. So in my career, I've seen so many times the difficulty in going from research to startup. So I've had the benefit of working within the post-secondary institution, and I often give this example of seeing incredible deep technology, often a researcher who's so busy, brilliant, and so busy, that it can be very difficult to take that technology to startup. When I was at Edmonton Unlimited, what I observed is brilliant founders, people who have that entrepreneurial grit, who know how to ask for money, who understand, taking that technology and marketing in a way that would attract venture capital if that's of interest for the technology. They often will have ideas inspired by the world that they know. And so I always thought, is there an opportunity to take what's happening in the university, this deep technology, which is a huge opportunity, and pair it with these incredible entrepreneurs that are sitting outside the institution to find ways to take those technologies to market in a really interesting way. So that's just something I always have been curious about, and would love to find a path to seeing that happen more frequently across Canada. Because some investigators feel pressure to commercialize research, but they just don't have the time and interest in creating a startup. So I would say, either as a researcher or as an entrepreneur that might be interested in partnering with research, ask yourself, how do you really want to participate in this commercialization journey? And if you're a researcher and wanting to create a startup, are you the CEO? Or do you want to hire somebody? Or if you want to be the CEO, who else do you need to have as part of your team to support your commercialization efforts? And what does your team look like? What are the skill sets that you want to have on your team, such as marketing and or business development, and or somebody who might have scaled that type of technology in the past before, a chief technology officer who's done this. And then, there's some resources you can access either through non-dilutive funding or through going and asking for venture capital to support this path forward. Because as you can see in this very busy slide, the path to creating a startup and startup to grown-up phase, as they call it, is not simple. There's a lot of different pieces that are required in order to make that technology grow. And what I really want to impress upon you is it doesn't happen overnight. We look a lot at overnight success, and it takes 10 to 30 years in many cases, not all cases. And certainly I don't think this is fair when it comes to certain tech-based technologies. I don't know if that it takes 10 to 30 years in those phases. But there are some in that sort of deep tech realm that can take a long time to get to market. So I think having patience, having grit, working with people in different parts of the team, demonstrating where you want to be and maybe where you don't want to be, are going to be really important as you're thinking about how you want to move your technology forward. So I'm asking for researchers, think about your team, your structure, equity, board structure, and advisory. And think about what you want to be, right? There's lots of examples. There's researchers like Dr. John Lewis, who I've had the pleasure of working with in my time, who's developed 2 big companies, Entos Pharmaceuticals and Nanostics, that have a presence here, both in Edmonton as well as San Diego. And they have great technologies associated with them. He's also hired some incredible people to support him as part of his teams. There's also people like Peter Cullis out of UBC, who really play a more co-founder role, and he's co-founded several biotech companies, including Acutus Therapeutics, which played a key role in the COVID-19 vaccine development. These ventures have helped to establish British Columbia as a global biotech hub. The article that I've linked here gives a good example of his impact and what he sees as beneficial in that space. And I really am inspired by people like him. And then there are other examples of companies that have thoughtfully brought on a CEO. Tivasol, which I think was recently acquired, had a CEO participating as part of their technology growth efforts, as well as Neurora, which is a smaller company based out of Calgary, supporting a new technology in PCOS. Great spinoff that came out of the university and has a seasoned CEO supporting the growth of that technology. So I would ask, if you're a researcher and or if you're a person in the ecosystem that wants to think of their next big thing, don't be afraid to work with the university if you're that entrepreneur, but also if you're a researcher, connect in with your incubators, accelerators, and other entities to support your journey, and maybe find CEOs and or other people on the teams if this is of interest for you. So there's a lot of information in this talk, a lot of examples, a lot of things to think about. But I think some key takeaways, at least I hope you can walk away with, is think about research through a commercial lens. There are some key things you can look at in an early stage to identify your IP and use a couple of those considerations. Access resources and supports to help you on your journey. When you're building a business, don't just think about the technology, think about the team. And there's no one specific path. I've seen so many, but there's lots of opportunity. Here are some references specific to slide 2. And that's the end of my talk today. Thank you so much for your time.
Thank you so much, Riya. That was absolutely incredible and perfectly on time. And that is very impressive. Thank you so much. I think we do have a couple questions here that I'll read out to you.
Okay.
I think one of them was answered during your presentation, but I'm still gonna say that one. Okay, so our first one is the tech that is developed from the researcher in universities the property of the university and responsible for any patents?
Yeah, so I think we touched on this a little bit. I did see that at the corner of my eye as I was presenting. Yes, so it really depends on the IP policy within the institution. If it's institutionally owned, then there would be the desire for the institution to likely own the IP. But again, even in that instance, there are some qualifiers around the policy. For example, if you come in with sponsored research and you've negotiated an agreement with the institution where you own the IP, then that might supersede the IP policy, but it really depends. And again, worth the conversation with the TTO. What I would advise for people who are interested in working with the university is not to let the IP policy get in the way of your interest in supporting a commercialization opportunity. Too many times I've seen people say, oh, their IP policy is just like, it's not worth working with them. Well, what a loss in terms of working with a huge potentially deep technology that can support your maybe your business in terms of its growth efforts on a go forward. So it depends, and then the unfortunate conversation, unfortunate piece. But I would take a look at the IP policy and have that conversation with the TTO.
That's great. Thank you. The next one is, should the projects be patentable before commercialization?
No, not in all instances, right? I think it depends on what you're seeing through the course of that assessment. So once you've kind of gone through the path of assessing the technology, the second question you can ask yourself is there a path to commercialization? Like the example we use is a trade secret example. You may be better off going down the path of trade secret or being first to market. That happens a lot, particularly with apps. Where there really isn't anything there that's patentable, but or not always patentable, but there's an opportunity to commercialize and maybe be first to market. So don't negate that. I would say there's a huge opportunity there, but I would also advise that, yeah, ask yourself through the course of assessment as well. There are improvements and other opportunities you might want to consider as you're working with the researcher. So if you're, or if you are the researcher, so we may say, maybe not this one, but I have this other idea, and this assessment has helped me support that next idea. So lots of ways to go forward.
Perfect. Perry, I hope that answered your question. If you have another one after that, feel free to post. There's one here from Kevin.
Hi,
Many
Kevin.
innovations we see from researchers are software-based and can't be patented. What strategies beyond patents, such as data ownership, partnerships, or rapid implementation, have you seen succeed?
Yeah, no, it's nice to see you again, Kevin. I've had the pleasure of working with Kevin over the years, and Kevin has a great connection in with post-secondary as well. So thank you for that and continuing to inspire, huge opportunities within the post-secondary space. I would say you're right. There isn't tons to do in that space in terms of patenting, but there are opportunities, I think, to think about beyond the patent and start to think about a monetization strategy. I think that's going to be a critical component of it, to ask yourself with the researcher, do you want to see a path towards monetization, and what could that potentially look like if you're looking at something like a software-based technology?
Perfect. Question from Sophia. How can we use Elevate IP and other IP programs to define the best protection, patent versus trade secret, for our core AI and align the strategy with pre-seed funding?
Yeah, no, ElevateIP is amazing. Like, honestly, this is a fantastic program that is nationally funded, and in my humble opinion, should remain a strong support for Canada. And the reason I think that is because what I see as a differentiator between ElevateIP and others is the ability to work with professionals to support that IP strategy. That's going to be your differentiator in the marketplace. So much of the effort sits on whether or not this is patentable, and that's fine. I think that's an important component of work. What I think universities have as a key differentiator, and that I think now the system has as a differentiator, is access to professionals who can define that IP strategy. So particularly in the course of artificial intelligence, which is changing on us rapidly, you do want to work with people who can understand what that IP strategy could look like. Is it an implementation strategy? Is it something that's going to be differentiated in the market? Do you need to be first to market and run really, really fast? These are the types of things you really want to think about to support your monetization efforts.
That's a really good answer. Thank you. We have one more here in the Q&A from Bola. He said, where do you think corporate innovation programs can play a role in bridging that gap between research and industry needs?
Yeah, this is a great question. So I think corporate innovation programs can really start to think about asking questions that can support corporations in their innovation interests. So corporations are doing core business, they're doing, kind of their core business strategy. There's this desire in a lot of particularly bigger companies to support innovation, but often it's like, I don't know how to do this. And I do think in that realm, asking corporations for their big problems, their big, hairy, audacious goals and problems, I would say even problems, and bringing that to the institution is such an important contributor to applied research and research that can support the direct needs of that company. I think that to me is a core differentiator for Canada, and not one that I see applied often. I do see that. I think UBC has done a fantastic job of connecting in, and I had the privilege of working there, working directly with industry, and it really, I think, finding that connection in with industry with the university in an increasingly global world where you're located doesn't really matter. You can be in Manitoba, you can be in Saskatchewan, you can be in Alberta, and the research is equally, if in some cases not more powerful. So don't let your location be the thing that doesn't drive that opportunity to work with industry. Many offices have strategic partnership offices. U of A has an enterprise office, which is quite dedicated to this effort. Start to work with them to say, can you work with industry, and ask them about their big problems? And then can we find research that can help to support that in a meaningful way? That I think is kind of the big gap I've seen.
That is perfect. Thank you, Ria. I have one more question from Perry in the chat. He said, any idea on how much patents cost?
It depends. It really depends. Filing can go anywhere between, at least my exam, from me, early stages, as low as 500 all the way out to $10,000. It really depends on the firm you're working with, and what you want to achieve out of that patent. I would advise, again, working with agencies like ElevateIP and others to help to support that journey, because it really does depend, and it really does depend on the needs of that particular technology as well.
Perfect. Thank you. And thank you, everybody, for joining. Thank you, Ria, so much for the presentation and for answering all of our questions. We are going to go back into the networking room and stay on for a couple more minutes. Yeah, thank you all for joining. I really appreciate it. And this will be up on YouTube tomorrow. So thank you, Ria. Thanks,
Thank
everyone.
you.